Thank you for coming out. Thank you for making it through the entire day. It's just me before the keynote. And thank you for coming to the most clickbait title of this track. Who am I? I'm Alex Tucker. I'm a dev manager at Wave. Wave builds accounting, invoicing, payroll, and payment software for small businesses. At job, my Wave is to help teams build and scale software that scales in both performance and in complexity. This talk comes from a lot of my firsthand experience in building large-scale, high-volume, and distributed systems, and kind of my never-ending quest to find a saner way to build these systems. So I'm going to tell you a little bit of a story, personal story. When I was learning to program, I went through this kind of natural progression of what seemed hard. And when I was first starting, syntax seemed hard. I would forget a semicolon, or I would just think I couldn't type. It was super annoying. And then I would get over that, and then logic got hard. Writing conditions. Should I use an and? Should I use an or? This is where you start learning about, code quality and how do you write clean code? How do you write code with other people? But there is kind of the final boss of how code remains hard, and that is around mutation. And mutation remains hard because as many tests as you want to write, you can never guard yourself when you have this kind of living system all around you. Your unit tests can't usually save you from race conditions. They can't save you from rogue signals or rogue background jobs changing state on you. And when you're in a distributed system environment in general, it's just really hard to think about all the application state at any given time. So as developers, the really hard thing for us is how do we actually manage that complexity and build systems that allow us to keep that model simple in our head. And this is where kind of the buzzword of immutability really comes into play. And I'm going to spend the rest of the talk giving you an example of how you should probably think about the concepts of immutability when you're writing your Django applications. So most of the time when we think about complexity in terms of mutation, people are like, oh, I don't have those problems. Those are like distributed system problems. That's when you're really big and you have lots of users. Those are like Google or Facebook problems. But they're actually, it's because you're writing a web application, you're already a distributed system. You have a client and a server. Multiple clients can hit your application at any given time. So you're actually a distributed system. So I'm going to show you the kind of canonical, crappy tutorial example that this is probably 1,000 iterations of this online. I have a Django view. I want to edit a blog post. So I fetch that blog post. I make a mutation to the content, and then I save it. But there's actually a hidden race condition in here that will bite you if you don't think about it. And I'm going to demonstrate it using the magic of comments. Okay, so client 1 has entered your code for a given resource, and they've now fetched that blog post. They're ready to make a mutation on it. Now, as client 1 makes that mutation, client 2 fetches that blog post, the same blog post, and it thinks the state of the world is what was on the DB. Client 1 saves that blog post. Client 2 is completely unaware that the state has changed. Client 2 saves that blog post, and if client 1 refreshes their browser, they're probably going to be really mad because they lost all the work that they did. This is an example of destructive mutation, and unfortunately for all of us, this is kind of how the world suggests that we should write our data. The Django ORM is designed to do this. It kind of maps an object to a database and suggests that you interact with your data through this type of API. And what's destructive about it is that when you change state, you can never look back and see what the state previously was. So let's look at this problem a little bit differently. At time 0, the content of a blog post might be foo, and at time 1, the content might be bar. The problem here is that at time 1, I actually don't know what the original value was in times 0. And that may seem trivial now, but let me continue, and I'll show you why that's important. So how could you possibly perform mutation without just editing rows in place? It's the way that we're trained to think about these problems. Well, turns out there's actually a different way of thinking about this, and it's a concept called event sourcing. And event sourcing is a concept of constructing your state of an entity from a list of changes instead of just a single row. You can actually think of it kind of like Git, but for the entities in your database. I'm going to show you an example of how to think the event sourcing way, and it's actually looks like this. And now, at time 0, think of it as more of a list. So at time 0, the content is foo. At time 1, you can see the state change from foo to bar. And if you simply selected the last item in the list, that's the current state. This is actually pretty wasteful. You don't need the entire state of your object. It also kind of loses fidelity. You don't know why that state changed. So there's actually even a better way of doing this. Instead of just snapshots, I now store the intent of the state change using event type and only storing the portions of the state that will change. You can see here in that blog post created, I actually store information about the author and the content, as you might want to when actually you create a blog post for the first time. But in T1, when I actually apply the blog post content updated event, I only have information about the content because I didn't change the author. My intent was to only change the content. So this is a little more complicated. I actually can't just select the latest item in this list. I actually have to replay over all of these events to get the current state of my entity. So how would I do that? Well, you can actually write some pretty elegant code using a reduce. You can actually just pass in your event log, write a simple function that knows how to interact with each of those different event types, and apply it to the previous state that was given to you. I've actually found thinking about state changes this way leads to a lot cleaner code. It has all the benefits of a state machine, and is much more expressive and kind of allows you to have an interface that's beyond just simple CRUD. It's the blog post change, not just the blog post, the blog post content updated, not just the blog post updated itself. Okay, so I actually haven't gotten back to my point, which is the original example of that race condition. So I need to do a little bit more setup for you, and I'm going to give you some real Django examples now. So in event sourcing, the main construct that you need to store state is an event log. And here's a Django model that you might use for an event log. First property is a GUID, probably a UID. This is the ID of your entity, not the ID of the item in the list. Then you're going to have some sort of sequence number. The sequence number is used to actually order the entities in that event log for that entity. And this will become very important very soon. And you need some sort of general way of storing the data for your state change. Coming officially in Django 1.9 is a native JSON field that works with Postgres 9.4 plus using their JSON B field, which is actually really awesome. So if I'm storing all of my state changes in this event log, how does that Django view example change? Okay, it's a little more complicated, so I'm going to walk you through it. So the first line is fetching the events for a given entity. And basically, when you fetch those events, it kind of works as that's the state of the world at that given time. And you're guarded by, actually, this one thing I forgot, this unique together over the GUID and the sequence makes it so that you can never write a sequence number twice to the DB. And this protects you from a parallel request coming in and clobbering your change. You'll simply get an integrity error, and then you can control what will happen coming out of that. So if I fetch the event list, now in my context, that's the state of the world for that entity. It's my job as a programmer to increment that sequence number, apply the new event, and write it to the log. So I'm going to run through using the magic of comments again and see how this race condition is going to play out. So client 1 comes in, fetches the event list. Client 1 has now gone, incremented the sequence number, and applied its change. Client 2 now fetches the event list. So client 2's kind of sense of the world is skewed because client 1 is about to write its changes. So client 1 saves its changes. Client 2 tries to write, is getting ready to write its changes. And client 2 goes to save its changes and gets an integrity error. And this is actually a really good thing, because before you would have never known about that race condition. You would have never been able to guard against it, and now you can. You can build strategies, you can just reject the request, and everyone, including your sanity and your users, are probably going to be a lot more happy about this. So you probably think this is a lot of work. But in my experience, as your systems grow, it's harder and harder to reason about state. And it's actually, the hardest thing is when the state of the world changes while you're trying to make a mutation, you really, really want to know about it. And this will get you around that. Okay, there must be some caveats, and I'm sure you're already thinking of them. This must lead to really slow reads. Because you're replaying this event log all the time. It gets even worse if you're trying to fetch a list of entities or do some data aggregation. However, one of the things I was talking about was that the source of truth is kind of maintained for you. And if you add a database transaction to the mix, you can actually write kind of a read-optimized version of that entity to the database, or hydrate a cache, and know that no one else is going to clobber those changes either, because that data integrity error you're going to get from your event log will reject the entire transaction on your behalf. You must also think, isn't that event log going to get huge? And what about my disks? My disk usage is going to be crazy. If you think disk usage is a problem, disks are cheap and readily available. Your data probably doesn't grow as fast as you think it does. And even if it does, there's techniques like database sharding that allow you to mitigate these problems extremely well. And that's actually what we do at Wave. What about kind of like read performance from event logs? Like, these tables are going to be huge, and even simple selects are going to become really expensive. Turns out the event logs, because the only way to really query them is to select the GUID, because you always want to fetch the entire history for an entity, you can index that field and get massive gains in performance on selects there. I want to touch on some of the other benefits of this technique that I can't really go in depth into, but I want you to be aware of them. So you have this entire event log, and you can basically, if you were to take the log and kind of move a window over it, you can actually see the state of that entity at any given point in time. And this is actually a really powerful technique for debugging your applications while you're writing code. If there's some really crazy stuff going on, you can take a look at the event log and see all the mutations that happened in between. It's actually even better in production, because if a user gets himself in a really bad state, you can actually go and look at that event log, figure out how they got there, and even help them get back to a good state. You could potentially roll them back to a version that was safe. Another thing that kind of comes out of this is that you get better analytics. So I'm sure most of you have probably had to instrument your application using Mixpanel or something like that. And that's because you want to capture the behavior of your users. Well, it turns out that your event log is actually just the behavior of your users. It's the intent of the state change, not just the change in state itself. So if you're really cool and you have a data scientist on your team or you have some BI experts, they would actually love to have these event logs and look at them and not just crappy pings to Mixpanel. The other kind of cool thing about this is that if some business person comes up with some other thing they want to measure, usually that you hadn't instrumented for that yet. But in this case, you have all of the event data stored for you, so you can actually go back and do historical calculations. Well, that's pretty much it from me. There is actually a lot of other side benefits to doing this. I'd be happy to answer any questions from you guys. Yeah, that's it.
So as he said, any questions? Was that a question way back there? Nope. There's.
I did notice that there are several Django packages that do model history. Do any of them, do they do the same approach that you're talking about, or?
And can you repeat?
Yep. So the question was, there's existing packages that do model history. So to the best of my knowledge, they take snapshots of the state, not the actual intent of the state. And it gets kind of lost in translation there's a certain level of fidelity that you get with capturing the intent of the state and not just a snapshot of it. And that's why we use this approach instead.
So I saw that in the example you gave, the particular, what you're calling the intent of the state change was, I think, update content.
Right.
My understanding is so event sourcing as expounded upon by Martin Fowler and company, usually they talk more about sort of business level events. At Wave, what are you guys using more sort of CRUD type events in practice, or is it more business objectives?
So the question was, how do we use event sourcing at Wave, not just for kind of CRUD-like actions? So I mean, this is there's two parts to this question. There's just a lot of confusing terminology. I don't mean event sourcing exactly in the Martin Fowler way, but we do use, basically we broadcast every single state change on our message bus. So consumers who are doing data aggregation can actually kind of leverage that state. And we actually, the interesting technique that we use is that whenever we broadcast those messages, in that data payload, we put the previous state and the current state. And that way, if you're smart about your data aggregation, you actually don't have to go back to the original source, and you get out of a lot of the kind of ordering concerns that you might have with asynchronous jobs and aggregation.
I'm not that familiar with Django, but I was just wondering why the problem you outlined with the client 1 and client 2 concurrently trying to edit a post. Why don't they use some kind of lock or something like a threading library you would use to kind of block? And then the next one that would come would have to wait until the previous one that you released it.
So the question was, why not use a technique like locks to solve this problem? So there's kind of two ways of talking about the Django implementation. One thing that, even before thinking about locks, you could actually be protected by a database transaction itself, where if someone tried to read a second time while you had a transaction open, you could actually inform the person who opened the transaction that actually occurred. Usually that's pretty tricky to manage, and leads to kind of a lot of false positives and rejecting a lot of things that you don't want to. Locks. Previously, we had actually used distributed locks, and I found them extremely hard from a cognitive standpoint to keep straight in my head, especially when you're kind of doing multi-entity type things. So if I was pulling in together multiple objects in my system and trying to apply mutations across them, you'd actually have to get like multiple locks to do that, and it didn't scale for us in terms of complexity.
Briefly mentioned something about optimized read, so if that's this kind of snapshot of the same point. So do you have more details about if you have a read-only view, like if you decide whether you replay the whole history or if you use a snapshot, and how frequent these snapshots might be?
Yep. So the question is, how would you use a read-optimized view? So a read-optimized view would have all the fields that your clients would want. And the kind of cool thing about it is you can actually pre-aggregate data for them. So things that they normally would have to compute on their own, or if there was a field in another model you want to denormalize into that, you can do that with a read-optimized model. That's pretty much it.
Cool.
So, sorry, one more question. In terms of composition on those reducers, to what extent have you created reducers that were dependent on other reducers, and how does it distribute?
We really try to avoid doing, have we run into the problem of composing reducers? So we really have tried to avoid doing that. And the main way we can get away with that is if you wrap all your changes in one database transaction. You can actually run one reducer for each entity, and if one of them becomes invalid, the entire transaction is going to get rejected anyway.
We got plenty of time for questions. Anybody else?
So if you're having multiple clients accessing, how do you handle collisions and synchronizations on state when one person or one client's deleted something and the other one's trying to do something with it?
So the question was about synchronizing state when one client deletes while another client is reading. And again, the event log will actually it actually won't save you. There is kind of an eventual consistency problem there, but probably a little more rare than, or at least I hope it is.
So what's the solution though? I mean, if you're using this in something like, I would think that Google Docs is using something very similar where they're sending events of edits rather than the document being edited all the time. So they're solving that problem. How would you solve it?
I mean, I don't have an amazing solution. We're kind of more interested in the per entity state change and kind of the kind of crazy diffing strategy that Google Docs uses. And normally the level of collaboration is not that great, but is still a problem in a distributed system.
Are you actually deleting entities at all, or just adding that this was deleted?
So the question is, are we doing soft deletes? So what we would do is we would write to the event log, like entity deleted, and then we would probably delete its read models. But the history of that model is still around.
I think you had a question, sir?
Yeah, I was just wondering, did you look at any other maybe state machine packages that might accomplish a similar goal? Obviously, you did a lot less with it, but like Django FSM or something.
Yeah. So did I look into any state machine packages? We took this approach and kind of just by proxy got a state machine out of it. It's not that we were looking for a state machine. We were looking for a safer way of doing mutations. And it turns out kind of going that reducer approach forces you to use a state machine.
Your example, we're looking at one single entity. What happens if we are looking at two entities, and from a business perspective, there are possible inconsistent states if we've made a change to one but we haven't made a change to another, so you could imagine a banking transaction.
Yes.
What's the situation there when you've successfully ensured that each entity's state is not being confused, but when you see them together, it's becoming consistent?
Yeah. So this is the exact problem we were trying to solve at Wave. And basically, because you can change two entities under one database transaction, if one entity's state becomes invalid during that transaction, you're going to reject both changes. Oh, and the question was, how do we deal with multiple entity changes? Yeah.
So can I ask a follow-up there? And this kind of builds on the earlier question about can't we do it, Django has select for update. It seems to me that there are existing database techniques that provide solutions to some of these problems, and in your own solution using the event state, you end up relying on those very same database techniques to solve the end problem. So really, I guess I'm just failing to see the example you gave at the start as motivation for doing this. There might be another reason for doing this, which you've given as well, but the example kind of seemed a bit weak.
Yeah, so the example has to be slightly contrived. I can only put so many lines of code on the screen, and I don't want people to wrap their head around the multi-entity issue, which is the real crux of the problem.
But I'm sorry,
yeah.
It's still going. The multi-entity issue can be solved in the same way, just using database transactions, where you're making the same two changes within your database transaction, and either they both work or you solve that.
Actually, the transaction scope doesn't extend to the browser. So what you end up with are
So there's clearly a discussion here that maybe could be offline. Sounds heated and interesting. But let's keep it for any more direct questions to the speaker.
Just a final question, where is this going, and any libraries out there that we should be excited about soon, or open sourcing anything?
So the concepts in here are really simple, and I actually would probably not open source it, just because I would actually encourage you to write it on your own. I think people kind of really over rely on tools, and I think there is a good quality to owning some of the tools that you use, and then this is an example of one that you should probably write on your own. Like the framework internally is like 100 lines of code, so.
Well, you have 5 minutes left. So. All right, then.
Okay.